the UK government has committed to net zero greenhouse gas emissions by 2050 and to an 80% reduction in emissions compared to 1990 levels by 2030. To achieve this goal, energy production in the UK needs to come from renewable sources instead of fossil fuels like coal and gas. There are lots of options for renewable energy sources like wind, solar, and tidal power. Nuclear energy also offers a low-carbon energy source. But how much renewable energy can the UK actually produce? And is it enough to meet demand? The UK has one of the best environments in the world for producing wind power. As an island in the northern hemisphere, we get a lot of wind and have a lot of coastline for building offshore wind farms. So how much wind power could the UK actually produce? To figure this out, we've got to use a bit of physics. If we consider a tube of air with cross-sectional area A travelling at velocity v, then the kinetic energy of the air is given by the following equation, where ρ is the density of the air. If we divide this by time, we get the kinetic energy per unit time, or the power that the tube of air produces. A real wind turbine won't be able to convert all this wind power into useful energy, as some wind will still get through, and energy will be lost to things like heat and noise, so we have to include a factor for the efficiency, C. If the average turbine has an efficiency of 50% and a blade diameter of 25 metres, and the average wind speed is 4.4 metres per second, then one wind turbine has a power output of 13 kilowatts. According to the Department for Business, Energy and Industrial Strategy, the current peak demand for electricity in the UK is 61.9 gigawatts. To produce this much electricity at once, we would need around 5 million of these 13 kilowatt wind turbines. To put this into context, there are currently around 11,000 turbines in the UK's onshore and offshore wind farms. Wind turbines are getting bigger, better and more efficient, but even with 10 times the power output, we'd still be a long way off. And where would we put millions of turbines anyway, even if we had them? So it's clear that wind power alone won't be enough. Luckily, there's other options. Tidal and wave power also seem like great options for the UK, since we're surrounded by sea. Wave and tidal stream energy is generated from the movements of waves and tidal flows. Wave power is much more predictable than wind power, and it increases during the winter, when electricity demand is at its highest. It is estimated that the UK has around 50% of Europe's tidal energy resource, and studies have shown that we could get 30 to 50 gigawatts of energy from wave and tidal power, which could really help us to meet peak demand. The problem is that tidal projects are very complex and very costly, and past projects have failed to take off. So tidal projects just aren't giving us the bang for our buck that we need right now. Another possible renewable energy source is solar energy. But the UK is not the best country for this. We don't have many days of sunlight per year, so we'd need to be able to store energy in sunnier months for use in the winter. And battery storage just doesn't really have that capacity at the moment. Currently, if each south, east, and west-facing house in the UK was fitted with 12 solar panels, and each solar panel had an average power output of 265 watts, this could generate up to 48 gigawatts of power. But that's a lot of houses. A company called the Eco Experts estimated that, with all panels in optimal conditions for catching sunlight, we would have to cover an area the size of Derbyshire, about 1% of the UK's total landmass, to produce the energy we need. While not impossible, finding that much available land would not be easy. Nuclear energy and bioenergy are also alternative energy sources, which produce less carbon than fossil fuels. Nuclear is low carbon and very reliable, but it does present issues with safety and storage of radioactive waste. Bioenergy is also low carbon and can help us manage waste disposal, but it is expensive and can cause deforestation. Neither's perfect, but they're still useful alternatives. So, if we want to phase out our use of fossil fuels entirely using renewables and continue to meet that 61.9 gigawatts at peak demand, it's clear we need an energy mix, a combination of all of these renewable energies which can meet our energy demand when used together. We have the capacity to get all of our energy from renewable energy sources in the UK, but that requires government investment, research and land space. Surely there's not a lot to sacrifice to protect the future of our planet. Thanks for watching, we hope you enjoyed this video. See you next time on Felix Science Explained.